related rates, we're always gonna be asked to find the relationship between the two unknowns. And in this case, it's v equals to x3, since the volume is the cube of the length of the side. And since v is 27, x is 3, dv over dt would be equal to 3x squared dx over dt. So we're asked to find dx over dt, which is equal to the rate of change of an edge of the cube. So negative 2, which is dv over dt as it's given in the question. Since when it says decreases, we put a minus sign in front, is equal to 3 times 9 squared, 9, which is 3 squared, since x is 3, times dx over dt, which gives us that dx over dt is equal to negative 2 over 27. Now this is what we were asked to find, so this is our answer. Now if you are asked to find the surface area, that is not equal to x, that is equal to 6x squared. And since df over dt, which is the rate of change of the surface area, is equal to 12x, then we already know what x or dx over dt is equal to, so all we need to find is ds over dt, which we can in this situation, and that is equal to negative 72 over 27, which if we simplify, negative 8 over 3 in this case. It's important in these questions to identify what we're being asked, and in this case we were being asked the rate of change of the surface area, so we found ds over dt to be equal to negative 8 over 3. In the second question, this time we have a cone, and we are asked to find a relationship between h, r, and the volume, which we already know. And we are given that r is equal to half the height, so r is equal to h over 2, and v is, as in the formula of the volume of the cone, v is equal to 1 over 3 pi r squared h. So since r is equal to h over 2, we can rewrite this equation as 1 over 3 times pi times h over 2 squared times h, which is equal to 1 over 3 pi h cubed over 4. Again, if we simplify this, that's equal to pi over 12 times h cubed. Now this is equal to v. What we are asked to find dh over dt. We are asked to find how fast is the altitude rising. So now if we take the derivative of this equation, dv over dt becomes equal to pi over 12 times 3h squared times dh over dt, which is what we are being asked. Then if we put the variables in, 12 equals 9p dh over pi dh over dt. So dh over dt is equal to 12 over 9 pi, which is equal to 4 over 3 pi. In the third question, first we should draw a sketch of what's going on. We have the wall, we have the floor, and then we have a ladder in between, which creates a right triangle for us. Now, the length of that side is increasing at a rate of 2 feet per second, as it's given in the question. And the wall's length is 8 feet. Since it says it's a 10-foot ladder, then we put 10 over there, which makes the length of the ground 6, since it's a right triangle. Now our equation is x squared plus y squared is equal to 100, which is 10 squared. Now if we take the derivative of this, then we get 2x dx over dt plus 2y dy over dt equals to 0. Now, we are going to put the values into our variables as it's given to us. The x is 6 as we found, dx over dt is 2 since the rate of change is 2 feet per second, y is 8 as it's found, and dy over dt is what the question is asking when it says how fast is the top of the letter will fall. So that makes 24 plus 16 dy over dt equals 0, which makes dy over dt equals to negative 24 over 16, which is equal to negative 3 over 2.
First, you need to draw a coordinate plane on which the train and the car is moving. Now we can count the y-axis as a track on which the car is moving and the x-axis as which the train is moving. So car's motion could be expressed as 10 minus y, since it says in the question that it arrives at the intersection 10 minutes before a train. So our train's coordinates, our train's motion would be described as x. Now it says that 10 minutes after the train crosses the intersection, so we need to first write our equation, but we need to find what the variables in our equation will be. So 10 minutes is 1.6 hours, 60 mph is 10 miles, and for 90 miles per hour it's 15 miles. So distance is 20, 15, so as in the Pythagorean theorem, the distance at this moment is 25 miles. Once we write the Pythagorean theorem, we need to take the derivative of this so that we can find a relationship between our variables. Then we get a 2x dx over dt plus a 2 in parentheses 10 plus y times dy over dt, which is equal to 2s times ds over dt. So now we can put the numbers we found into the variables. X is 15 at this moment. Dx over dt would be 90 miles per hour. And then our y value is 20. We can find all of these variables from the question. And then our dy over dt is, as we calculated, 60 miles per hour. So then we know the s from the Pythagorean theorem is 25, and now all we need to find is the ds over dt from the equation. And now if you do the math correctly, you can find that ds over dt would be equal to 102 miles per hour.
In the last question of this worksheet, our related rates relationship is a trigonometric one. Now first we need to determine that the length of that side is 5, since x coordinate is 5 at that point, which makes tangent theta is equal to y over 5. So if we take the derivative of this, secant squared theta d theta over dt is equal to 1 over 5 dy over dt. Now we are asked to find the rate of change of the angle theta, which is equal to d theta over dt. So that's what we're looking for in this equation. Since we are asked to find this when y is equal to 15, we put it into the sketch, and we find that the hypotenuse is equal to 5 root 10. So secant theta is 1 over cosine theta, which is equal to, in this case, 5 root 10 over 5, which is equal to 10. So secant squared theta is 10. dy over dt is the rate of change of y, which is already given, 10 units per minute. So so we get 10 d theta over dt equals 1 over 5 times 10. Then those 10s cancel, and we find that d theta over dt is equal to 1 over 5.